Welcome to Module 1 of our class, and we'll start with Part 1, the big picture. And the objective of the whole module is to introduce you to some basic of networking and specifically to introduce you some ideas of the big picture, how internet is organized, and how things are working together. So first of all, we can start with the terminology. Our internet is huge. There's a lot of different things that exist in there, and specifically there are several important terminologies that we're going to be using throughout the class. So first of all, we have systems that effectively connected to the network or connected throughout the network, and we call them hosts, or sometimes we also use the word end systems. And these are the effectively machines, computers, smartphones that are running the network applications. And we're going to talk a lot more about the network applications later. The next element of the network is the communication link itself. So it's effectively something that connects the network together. It's either the fiber link or some kind of a copper, radio, satellites, and so forth. And among parameters of those links is the bandwidth, and as we will talk more in the part 2 of this module, there is also delay, there is also kind of various types of delays, there is losses, and several other characteristics. And finally, there is a category of elements in the network, like extremely important elements in the network, is packet switches. And there are two types of packet switches. There is specifically routers and switches. Sometimes they're used interchangeably, but sometimes they actually mean slightly different thing. And as we talk more about the layering model throughout this module, you will learn that routers is something that is doing a networking level job, and you can consider them smart devices. And switches are primarily designed for the layer 2 or like link layer operations. And you can think of them a little bit dummier devices than routers. So kind of talking about the overall structure of the network and nuts and bolts of the network. So you can think of internet as not just a network that connecting all devices, but rather it's a network of networks that connecting the devices. And there's actually can be multiple levels of those networks of networks. And not completely formally, you can think of them as institution networks. Something like FIU has a network that connects the devices of a specific institution. Similar thing can exist in companies. So company networks, home networks, individual home like you have at home. That's another category, but both of them that I just mentioned are networks that specifically designed, the work for the consumers, and not really something else. So they only kind of generate requests for the traffic, or maybe provide some form of a serving of the website or similar things. There are several other types of networks that have slightly different category, and specifically these are so-called ISPs, or internet service providers. And they're also categorized in several different categories, but in any case, the job of ISPs or ISP networks is to forward packets. So they then don't really by themselves generate the packets themselves or generate requests. The only job is to forward from one network to another network. So as you can see on the picture, they would forward the packet from the home network to institution network and back and forth. The difference between this regional and global ISPs that mentioned on this slide is simply their position in topological space of the whole network. So if you consider regional ISPs, it's something close to the consumers, effectively, close to the institutional networks. So, for example, AT&T, if you use AT&T at home, or Comcast, if you're using Comcast, that would be institutional network for you. Oh, apologies. That would be a regional network, regional ISP. But the regional ISP, effectively, because it's relatively local, can only connect networks within that region. So that's why kind of on the internet there is also a class of ISPs, and they're very limited number of those that can be called global ISPs, or sometimes actually referred as a tier 1 ISPs. And regional can be kind of designated as a tier 2, tier 3, or even tier 4 sometimes. And kind of as a small ungraded assignment for you, if you really want to do, is to discover how many tier 1 ISPs exists in kind of in the universe. You can go on the Wikipedia page and just type in a tier 1 ISP. Okay, but switching forward, so another element of the network, an extremely important element of the network, is the protocols. We'll talk a little bit more about the protocols, but to give you a completely random example of what kind of names of the protocols in existence for the networking is just, for example, is TCP, IP, HTTP, dash 802.3, 802.11, and so forth. We're going to cover all these protocols that I mentioned and many others in a little bit more detail in the later modules of this course. But just to start getting familiar with a lot of abbreviations that we're going to be using. So one important note that I want to mention here is standards. So one thing that is extremely important for having the internet, like having the ability to interconnect between different things and interoperate, is something standardized. Like how you communicate across different applications, across different operating systems, across different using different routers from different vendors. You have to have some kind of a common agreement between them of what they're communicating about. And so what we have is so-called internet standards. Well, there's many different standards, and there are multiple different organizations that actually are designed to provide this standardization body for such standards. And one of the common ones is IETF, Internet Engineering Task Force, that kind of provide the standards in form of RFCs, or requests for comments. It's kind of interesting name, but it is actually a standard. The requests happen a little bit before, like during the standardization process, but after things got standardized, it's already standard. So the other one is IEEE standards. So this is like IEEE organization that define a lot of different standards for link layer, MAC layer stuff. Okay, I shouldn't use these words. Standards for communication links, like something like how you communicate in fiber, how you communicate in Ethernet, how you communicate over Wi-Fi. But there are some more standards beyond that. And I mentioned here is also W3C, and have more additional stuff on a different slide. So these ones are more application level standards. Even though there are bodies for these things, you don't really have to have a standard on application side unless you want to interoperate, and then it becomes extremely important. To give you example and why we have this W3C, so this would be World Wide Web Consortium, is that you have to have a standard on HTTP, you have to on HTML, this is our web pages, and some kind of a style sheets to actually format the page in the same way. Because a few years back, if you may remember or not, or if you had any experience writing in the web pages for web pages in general, you have to consider each individual web browser, like the logic built in the individual web browser, to actually format your page in a way so it's looked similar in different way. And that was effectively the problem of not having a common standard for web styling. Like they're still using the same HTML, they're still using the same CSS, but they have a different interpretation of certain things. And if they had a standard for this interpretation, then we wouldn't have this problem. Right now we have a standard, so things are getting better, but we still sometimes having some discrepancies. But let me move forward and kind of re-emphasize the importance of the protocols. So I just emphasized the importance of standardization of the protocols, but that's kind of a little bit separate from the protocols themselves. So in order to actually do any kind of a communication, you have to have the protocol defined. Kind of in real life, and I'll try to go over the real life stuff. We kind of don't necessarily explicitly define those actions, or like we kind of learn those protocols early in our life, like in kind of primary school and middle school and in university. But you have to define them formally, and you have to define them kind of in semi-standardized way for computers. Otherwise, computers cannot communicate. And the protocols effectively exist on all levels, like be it application, be it somewhere in the network, be it somewhere like on the physical layer. You have to define everything as a protocol. And kind of to give you idea what the protocol is, like if I try to define what the protocol is. The protocol is simply some kind of a specification. And that specification has three components. So first of all, it defines the format of the messages. It defines the order of messages sent and received, and it defines actions taken for those messages. And before I go forward, think of it as kind of the protocol, the concept of the protocol, and especially how it's defined here, is quite broad. I didn't put the word network protocol, but rather just protocol, because it also applies to real-life interactions. And I can give you a few seconds to think of what kind of human interactions you can define as a protocol. I mean, there are so many different interactions. For example, checking the time, interaction with the people, that can be the protocol. Okay, we don't really define that very, very formally, but if you're a very polite person, the polite way in United States would be to ask in English, first of all say hello, then ask what time it is, and the response from the person who received the request would be to respond with the time. So this actually already defining elements of the protocol. And if I do it a little bit more formally, so this kind of what I was trying to lead to. So if you formally define the greeting protocol for United States, for example, so you have to say that its format is verbal, like using words in English. And then you have to define what kind of words you're going to be saying, like what's order. First you have to ask how you're doing, and then there has to be response like I'm fine, or some other variants of these two. And finally there is action of this, effectively formally define that if you receive request, how are you doing, you respond with I'm fine or not fine if you're feeling sick. And similar for the time checking protocol, again, you can define it in English, you can define a set of phrases that you can use to ask for the time, maybe even have to have a dependency on the greeting protocol. So in order to start checking, you have to greet the person before that and then ask the time. So this effectively defining all these formal interactions. And I gave you a few more examples, like question asking, kind of if we had the real interaction, that would be nice, but effectively by using Canvas, I have defined some form of a protocol that in order to ask a question, you have to go to Canvas, you have to open a specific place and find the kind of box to click, box to ask the question and send the question. So that's kind of also the type of the protocol. So just keep in mind, so the protocol themselves is these three concepts, but if I move towards the network protocol, is kind of same thing, like a very same thing as I just talked about, these human interactions, but in much more formal way. Because depending on what we're talking about, it's you still have to define the format, you have to define the messages, you have to define specific language. You may need to define the channel through which you're communicating, because before it was just a kind of air sound channel that voice channel that I can communicating, but for the computers it has to be actually defined more specifically. The order of messages and responses, you have to define all the sequences in some form of either like a flowchart, if you can program the flowchart, or some kind of logic in the specification, and define when to start, when to respond, when to stop the process. And already I'm a little bit repeating the same thing. In addition to what I already mentioned, is a 3GPP organization that defines the GSM, LTE, and all other cellular standards. So this is kind of very important part. And kind of the part that I already mentioned, that protocol doesn't really have to be standardized, but it really also depends on the level of the protocol. As we're gonna go forward, there are a few protocols that have to be, everybody have to agree on a common ground. For example, if you're talking about GSM, if you want to talk on GSM, if you want to create the phones that can connect to GSM network, you have to have the standard. But if you're writing a simple application that only your application will communicate with your application, like on the other side, then you don't really need to standardize this part, or at least for the experimentation purposes, you can start with defining whatever the protocol you like, and then standardize this one. And kind of as an example of this is our homework 2, where we're going to be actually or not homework, apologies, the project 2, where we be actually defining, I mean, already defined, you will be implementing the kind of equivalent of TCP protocol. So that one is not standardized, but because I defined that specification, because I just put on the website and everybody will be implementing the same protocol, we effectively kind of have their own micro standard here. Okay, so, and just to give you a comparison between the human and the computer protocol is, you can see on a slide. So in a human interaction, that would be hi, got the time and got response of the time, versus if you're talking about HTTP. Okay, so this one is actually, it's HTTP process, where I have to set up the connection first. There's a process for the setting up connection. Then I'm sending the request and kind of processing the reply. This is like extremely simplified form, and we're gonna learn like a little bit, like a lot more details of how things are working in HTTP and TCP specifically. And finally, we got to the point of looking at the networking at kind of different levels of how you can look at the networking. So I put this nice looking elephant, and for one kind of important reason. So the elephant is big, so is the internet and the networking in general. And you can look at different parts, at different stages of the networking, and see slightly different pictures, or completely different pictures. So kind of as you look at the elephant from the side, that would be one thing, and from the maybe opposite of the head, that would be a completely different thing. So what we have in networking, kind of if you start thinking of the levels, so you can preliminarily define this 4 levels. So there are several models that I will talk more. If we're talking about the current TCP IP model, we actually have 5 levels, 5 views. I'm listing only 4 here because the last one is a physical layer view, and kind of this one is beyond the networking class. But it's also its own view, its own kind of interpretation, how to deal with things. So if I go over kind of very briefly, and then I'll try to go into more details of each. So in the application view is this is the application. This one, the web browser is trying to interact in some way. So the web browser, or you who run in the web browser, you're only interested in getting the web page. So that's the only objective. You know the address, and kind of the web browser knows that it needs to request that web page from the remote server, and it has some API to send that request. That's all the application care about. It knows the name of the web server and know the concept of some form of APIs. From the transport perspective, it's slightly different picture. So the transport view actually doesn't know anything about the domain name, so it doesn't know google.com. It only knows about IP addresses. It it knows that there exists something on the other side, and it also may provide some form of a reliability between kind of two nodes. But the one important part that I'm jumping a little bit ahead here. So the transport level is actually connecting the application to the network. So it still has some part that is connected to the application and just views the network as a black hole. The next level is a network. So this one is actually completely not concerned about the application, but rather the network level packets. And the objective of this level is to view network as just collection of routers, even though a lot of things are end hosts, but end hosts also doing some router operations. And we're gonna get there. And finally, the link layer view is just between two endpoints, or two routers or whatever, on the same physical channel. So, for example, be it Ethernet and two nodes on the inner Ethernet, or it's Wi-Fi, two nodes on Wi-Fi, or a little bit more complex is the cellular networks. So those have quite a bit strange structure that we're gonna talk in one of the modules later in this class. But let me get a little bit more details of this individual application views. So as I said, the application, we view the network as a completely black box. So we don't care how exactly things are connected. We don't care whether it's working or not. So the only thing the client, in this specific case, the web browser on the computer, is interested in kind of sending the request to the server and getting the reply. Actually, it's in slightly different way. It's they only care about the reply for the request. It doesn't really care about how this request being sent out or where exactly, and just getting the reply back. It doesn't know anything else. So you may know about the kind of the CNN.com as a domain name. It may know something about the security, that it's HTTPS or something, and something like that, but nothing more. And as I said here, so it's kind of at the application level, it may assume that the network or whatever below the application view will provide the connectivity to the other side. If we require reliability, so then that kind of we're going to deliver all the information that we're sending to the other side, and we receive the information from the other side. This actually not always required. So for example, for the voice applications, this is not the case. So the application view of the networking is quite simple. So it just assumes there is some form of a connectivity. Okay, that the network or something below the network, like in this specific case is the transport level protocols, will take care of all the delivery of the packets or whatever data to the other side. And if reliability is required, it will simply assume this reliability is provided by the low-level protocols. The application itself doesn't bother if it's required. It doesn't bother to actually check in any validity of the data. This may create other types of problems and may not be always true, but that's kind of the basic model. So if you want the reliability, you just select the transport protocol that provides reliability and use that to send receive data. If the application doesn't require reliability, like voice over IP applications, so then you select that protocol, that transport layer protocol, and then simply start sending packets. And in the application logic, you have to have some assumption what to do when you're not receiving certain information. Okay, so if I go forward to the application roles in the infrastructure, so it's effectively something to provide the very, very high level. It's either to actually realize the applications or providing very high level concepts, like high level APIs to the application. So what is being hooked up is to the network level. It is hooked up to the transport layer protocol through so-called sockets. And those sockets, so this one we're going to be really looking into the project one. This one is simple, don't worry about that. But effectively, the socket is something that connects the application or the application protocol to the transport layer protocol. So it's kind of having a bridge between two. And you can think of this so-called socket as effectively the outlet in your apartment, where kind of you want to, your lamp is an application, you want to get electricity, but you want to connect this lamp to a nuclear power station. And by effectively plugging in into the socket, you add in this application to one of the distributor channels so it can finally receive the electricity. In the network, it's much more complex than just simply receiving the electricity. There's various ports involved if you're talking about TCP or UDP protocols. But essentially something like that. Like in the application, you create a socket, and through the socket, you start communicating. And there are several options. I put here analogy to the postal service because you still have to have some form of identification of where you want to go, at which kind of city, to which node, to which application on that node. So all those information is actually provided within the transport layer protocol. And examples, so we'll talk more about the transport layer protocols in a few seconds. So to give you an idea of the application layer protocols, or at least examples of them that we're going to be covering in much more detail in the module 3, is kind of, there are several ones. So there are several that depend on reliability, and I think that would be the most of our kind of discussion. So the web, the most important one for us today is a hypertext transfer protocol, HTTP, that I already mentioned a couple of times. And it actually has an extension of like secure extension as HTTPS. So this one we're going to be talking also as part of the module 3. So there's other protocols that you may not heard too much, but you definitely used. So one of them is SMTP. So this is how we effectively sending emails across the network. Even if you use Gmail, Gmail behind the scenes uses SMTP protocol to send messages back and forth. It actually format messages, define how the kind of sequence of sequence of messages to be sent out, and some kind of headers, and what to do when receiving the messages. And finally, there's a domain name system, or DNS. So this one is actually extremely important for today's internet, and defining how we convert from this nice looking google.com to something that networks can actually operate, and that it can operate today on IP addresses. So for another important part that we're going to cover in the module 3 is the objective of the application layer protocol, because different applications have different requirements. They have different requirements from the network or from the transport layer protocol. And depending on those requirements, we need to pick different protocols. So we'll try to kind of think of what kind of design issues in existence and how those design decisions can impact the application design. But moving forward to the transport layer view, so again, in the application, we were very high level. We viewed the network as a black box, or actually, we didn't even see the network because we just looking for the responses that we want to get, or some kind of connection we want to get. At the transport layer is something is similar to that, but we get in a little bit more specificity. So at the transport layer, we still viewing the network as a black box, but we no longer have the application kind of application logic. So what we need to do at the transport layer is to receive something from the application and package it in whatever needed format to be delivered to another application. So it's kind of as a transfer between one application on one side and an application on the other side. And what needs to be packaged is actually several elements. So we need to address the node, we need to address the specific application, a destination application, source application, and whatever other identification information is needed. And specifically what kind of those transport protocols care about is if the application requests reliable delivery. So this is the transport layer job to figure out how to deliver packets reliably. And by delivering packets reliably, I'm actually meaning if it needs to detect that if packet was sent out and was not received on the other side, it needs to be retransmitted. And it needs to be retransmitted until that the other guy kind of confirms the reception of the packet. Or if that function is not required, it still have to have an ability to send the packet to the other application. And that part is actually can be formally called as a demultiplexing, or multiplexing and demultiplexing, because from one side the transport layer protocol receive data from multiple different applications, so they need to multiplex everything into one stream going out of the computer, and on the other side it needs to receive effective stream from the internet and demultiplex to different applications that's running on the system, if they even exist. And there's another one that I mentioned on the slide is a congestion control. This we're gonna also do a little bit of that in the project too. So the congestion control is an interesting topic. I will talk more about this, but to think of kind of to give you a very high level idea what it is, it's more like trying to control amount of traffic going into the network. And kind of analogy is basically our freeway system. So if you kind of add many more cars into the kind of fixed capacity freeway, at some point nobody will be able to go anywhere. However, the interesting difference is in freeway system, the only thing that you can do is to not allow new cars to get in. So you have to block the road or do something about that. In the internet, you can actually drop some of the packets. So like if you get new packet or like the packet is staying in a system, you can start dropping it. That would be equivalent of kind of taking cars from the freeway and throwing them somewhere away. Obviously, it's not possible to do in kind of in real life in the freeways, but something that can be done in transport layer protocol. But effectively, the congestion control is trying to control the amount of traffic being pumped in the system in order to make sure that everybody is receiving their fair share of resources. And in more detail, we're going to be talking about the transport layer protocol in module 4. And your project 2 is actually very heavily kind of dependent on your understanding of the transport layer protocol. And we're going to cover the roles of transport protocols, principles of implementation, principles of congestion control that I just mentioned. And we basically cover a little bit more detail in individual kind of common transport layer protocols that are currently in use. So specifically UDP, TCP, and a few others, but we'll try to go over them quite quickly. Okay. So now we kind of have some understanding, I hope, about the transport layer protocol, but they don't actually do the delivery. So they only assume that somebody will deliver actual packets to the other node, but still don't really care how things are happening inside. So this is the actually job of the network layer, or like network layer view. So at this point, then kind of the transport layer, there's no longer application. So there's nothing like that. So the only thing that exists here is node and all nodes in the network individually. And what we care about, or like what the network layer is kind of designed to do, is to figure out a way in this network of interconnected end hosts or interconnected routers to find a path from your computer to that Google server. And that's not easy task to do, and that's what kind of the network protocol is designed to do. And if I refer back to standardization part, so this is the place where you have to be on very, very common ground on how you actually communicate across the whole internet. And kind of today we have IPv4 and IPv6 as a kind of two major standards that everybody agrees upon, that this is the way we intercommunicate. And then there's a bunch of routing protocols that actually figure out the way how to and they figure out the way of the different paths through the network, and the network layer is effectively executing the decision provided by the routing protocols. So the connectivities in the internet is quite complex. As you will be able to see, I think I will try to assign you one of the homeworks that where you need to explore some of the parts of the internet. But the internet is really huge. Like, I cannot even count the number of computers connected to it. But everybody effectively needs to be able to communicate with everybody else, or at least in limited capacity. And it's not easy task to do. We're going to cover a little bit of principles of routing protocols, and we cover specific types of the routing algorithm and specific protocols that are designed for different purposes a little bit later in module 5, I believe. But what I want to emphasize here, that at this point, things can go wrong in different ways. And there are multiple tools that provide you ability to actually start debugging the problem. And there are two specific tools that I want to introduce you right now. One is called ping, and the other one is traceroute. All of these tools exist on all operating systems. If you're using Linux or Mac, this will be the variant of those tools. On Windows, the traceroute is actually called, I believe it's slightly different, but if you Google how this tool is called on Windows, you'll figure it out. And the output would be pretty much similar. And what you can do with these tools is so-called. So with the ping tool, you can check if you can actually reach a specific destination. And by destination, I mean a node of the network. And you can either specify the host name or like the main name of that node that will be converted to the IP address using DNS system, and that will be actually checking that connectivity to that IP address. Or you can specify the IP address directly. Sometimes, as we're going to cover later in the class, sometimes the domain name doesn't point to a single IP address. So if, for example, if you do pinggoogle.com at home, you most likely will not ever gonna get this 172.217.110, but you will get something completely different. There's a few tricks that we'll cover later. So that's why sometimes you need to specify the IP address in order to actually get something useful from that. And the other tool is traceroute. And the traceroute allows you to approximate the path your packet is taking throughout the network. And by path, I mean how it's flowing from your host system to the next router, from the next router to the next router, and so forth until it reaches the destination. And when we're going to be talking about the network level and specifically IP protocol, we can actually figure out how the traceroute tool is realized. But for now, just think that the traceroute can kind of give you the approximate path. Note that I'm using the word estimate and approximate because this is not the exact path, and these IP addresses may not be really representing the actual path your packet is flowing, and I'll try to explain this more in the future. But for now, you can take that this is some kind of a path. And one note here, as you may notice, again, depending on where you are, depending on what kind of trace route you're going to go to, you may see different things. And kind of this can be picture can be completely different. But what you can see on this one is that at the hop 7th, or between 7th and 8th router, there is a different IP addresses reported. So it's kind of the system saying that one packet that when we're sending out between 7 and 8 went through one router, and at the other point of time it went through the other router. So this is kind of effectively done on the internet for the kind of balancing purposes. So sometimes, or not even sometimes, like packets don't really have to go through exactly the same path to the destination. They can be deviated so they can find the more optimal path, less congested, or simply kind of balanced path for the purpose of that ISP. But there are many more techniques that we will kind of learn later in the class. And as I said, it will be in module 5. In addition to talking about the traditional networking of the internet, which is like packet switching, we're going to talk also a little bit about the circuit switch networks. So this one is a little bit different thing. We actually went away from circuit switches already, but we had them like during telephony networks. And that's kind of it for the introduction. And what I want to say, so the network layer, kind of, even though we see the network as many hosts, or like many routers in a system, at the network layer, we absolutely don't care how actually packet flowing from one host to the next one. So we just only know that you can send packet from router 1 to router 2. That's it. So we know that the path exists, and we know that we can do it. But how exactly we can do it, this is not the job of the networking. This is actually the job of the link layer view. And the link layer, we actually trying to figure out how to do this job, how to send the packet from one adjacent node on one side of the link to the other adjacent node on the link. And I already mentioned it can be either fiber optics, wireless, or like old stuff like a twisted pair and other things. I think we're going to cover several items for this part. That will be the introduction to the Ethernet, introduction to the Wi-Fi, and depending on how much time we're going to have, maybe some other additional introductions. So effectively, this is what all I wanted to say about different views of the layers, and what kind of to specify and give you a little bit more details. So this views actually been formalized in several different ways. So the commonly that what we using today is the so-called the TCP/IP protocol stack. Names are pretty much the same that I have been using before, with exception that the network layer is called internet, and I also added the physical part here, so that this is an additional layer that exists in reality. And the physical simply means it's the way the signal is being modulated. So it's so at the link layer, it's about how the frame being delivered from one node to another node, and a physical is simply saying this is the air, and in order to use this air, you have to modulate in a specific way, kind of that signal. So the link layer, this is Ethernet, Wi-Fi as an examples. You could transfer data between directly connected network elements. On the internet, this is today is IPv4, IPv6, and kind of routing protocols. They partially belong to the internet, partially belong to application and transport. So the kind of the role of routing protocols is a little bit fuzzy. But in any case, the idea of the internet layer is to forward packets from source to destination. Again, not caring how exactly it's done between each individual router in the network. Then the transport layer, I already gave you examples of TCP and UDP, and just trying to multiplex from the application traffic and demultiplex to applications, plus providing some reliability, congestion control if that's required for the application. And finally, the application layer is everything that's done beyond that. Like HTTP, SMTP, dashed, so this is for video, some various voice over IP protocols. That's everything at the application stuff. So the reason I said kind of TCP/IP and what we're using, kind of the commonly using, so that was the model. Or that is the model that what we're using. But I think if you open the book or open many other things, or if you're looking about layers, you most likely will see this OSI protocol stack or OSI model. So this one was actually first designed before the TCP/IP. but somehow didn't get standardized. Or standardized as part of the IEEE, but it's not really standardized as part of the application. But in any case, it looks pretty much similar, and kind of the first 4 layers is basically exactly the same thing, and instead of just having a single application layer, there's 3 additional items. So there's application, presentation, session. So effectively trying to formalize a little bit more these layers at the application, because there are different things bundled together. But in reality, we don't really talk too much about the session representation or just bundling everything as part of the either application or either transport layer protocol. Because in TCP/IP, some element of the session belongs to the transport and some elements of the session belong to the application. And kind of to finish about the protocols, I'll try to give you some analogy with the layers versus the postal system. So this layering kind of exists as part of the message sent. So let me phrase maybe a little bit differently. So when our internet is packet switched network, so everything that we send out has a form of a packet. But on different layers, you're looking at different part of this packet. And effectively what exists, like if we kind of forget about the physical layer, because on physical layer we don't really have anything like packet. So the packet starts at the link layer. So at the link layer we have the frame. So this is like a unit of being transmitted between 2 hosts, and that frame contains some form of headers that identify which destination on this kind of link needs to receive the packet, some additional headers, whatever needed for the transport for the link layer protocol, and additional kind of pointer to identify which network protocol needs to be used. So that's kind of one kind of outer envelope. And if you consider the kind of the big envelope for that, so this would be the actual envelope and the address written on the envelope. Like it needs to be delivered to wherever, here and there, like to FIU somewhere, to myself in FIU. Then there is a network layer protocol header. So this one is still packet within the link layer protocol packet, and but now it has its own headers inside. So those network layer protocol just simply identify what the IP addresses, the kind of destination IP address, source IP address, and some other information that's relevant to the network layer protocol. And I'm not sure what would be the exact analogy for the network protocol for the envelope, but we can talk more about this later. At the transport layer, so there is a transport layer header. So this one includes elements necessary for demultiplexing, multiplexing, and whatever the flow control, congestion control, and reliability information. Then we have the application protocol. So this one becomes a little bit more fuzzier because there's not necessarily headers, but some kind of information for the application to determine what needs to be included. So in many cases, the kind of headers just come in front of the packet. So like the application generates data, it puts some headers in front, it gives to that transport protocol, then the transport protocol maybe chops that application protocol data into pieces, adds its own headers, give it to the network protocol. Network protocol either just adding its own headers, or maybe even chop the transport protocol packet into sub packets, and we'll see that in next module, and then given to the link layer protocol. And link layer protocol can do something similar, either just add the headers in front, maybe something at the end. If it doesn't fit, it can also additionally chop that packet into pieces, and you have each individual piece would have its own header. And I will give you basically assignment to think of how the mail system or how the envelope is actually playing the role of the packet here. So you can again think a little bit more yourself, and I guess let me put that assignment as part of our discussions on Canvas. Okay, so to summarize, so internet is huge. It's made a huge number of hosts and routers. Like everything is interconnected by physical, or like wireless is also part of the physical links, and everybody is running some protocols. The hosts is effectively are machines that are running the client application, client or server applications that actually generate some kind of a traffic. Well, it's either requests of something of some sort or responses to incoming requests. Routers is on the other hand, routers by themselves also can have some host functions. So don't think of router that is doing only router function. But routers, if pure routers, they simply do packet forwarding. They don't run applications. Well, the routing role doesn't run applications, and that their role is simply to forward packets. And for the protocols that we have, like everything is running the protocols, but protocols can be categorized or organized in layers, and we covered those layers as application layer, transport layer, network layer, and link layer protocols. And as a side note, there is also OSI model that splits the application and transport layer to a few more. So there's a application, session, and representation, to these three, and also transport layer. But again, some of the functions can be mixed together. And so this point is actually from the next, from the part 2, so I'm skipping this part. I'm assigning you a few more extra readings. So one of them is just a big picture of the internet, kind of interesting reading, and you can read more about the TCP protocol layers and OSI layering model. Layering. So that would be it for part 1. If you have questions, feel free to email me through Canvas, and hope to see you next time.